Welcome to the second lecture of Module 9. Now that you're familiar with simple definitions of vulnerability, resilience, and adaptive capacity, we can move on to explore a few of the specific strategies that can help us adapt to the impacts of climate change. In this lecture, we'll be exploring broad categories of adaptive responses. Within each of these categories are specific examples of adaptive actions that some communities are already taking around the world. These categories include ecosystem conservation, supporting developing countries to get at the roots of vulnerability, preparing for climate change through infrastructure choices and other actions, and simply learning more about what's happening and what's to come. Then we'll consider a pretty exciting trend in adaptation that's just emerging, ecosystem-based approaches. We'll wrap up by learning a bit about a small island state, the Maldives, and how it's dealing with the threat of rising sea levels. As you learned in Module 7, climate change is already having significant impacts on ecosystems. Higher temperatures and more intense or unpredictable precipitation events are pushing ecosystems into new territory. This often means that ecosystems shift to higher latitudes, leaving behind areas that aren't favorable anymore. This has a couple of repercussions. First, species that are fragile or whose preferred habitat exists on an edge, such as near the top of a mountain or a coastline, can simply be pushed into extinction. There's a human dimension to this, of course. We depend on a particular mix of crops, and so we're vulnerable to the increase in prices that will inevitably follow if these crops begin to fail or require significantly more capital to produce. This image, for instance, shows a map of the part of the world that I'm sitting in right now, the lower mainland of British Columbia, Canada. Here, the climate supports crops like apples, potatoes, and in some parts of this province, grapes, plums, and peaches. Some scientists predict that with rising temperatures and changing precipitation patterns, this region might support hot climate crops like pecans, olives, and even avocados within this century. This means a transition in British Columbia's economy and a stressed supply of some foods over others. So how do we adapt? Part of the answer is to anticipate the ways that climate will change and plant crops that are amenable to that change. Another way is to preserve the conditions in which the current crops thrive, either through greenhouses or changing irrigation practices, for instance. The same goes for ecosystems more broadly. This type of adaptation requires us to preserve the habitats of vulnerable species by creating protected areas, dealing with habitat fragmentation, and in some cases, supporting the shift of ecosystems onto new territories. The second broad category of adaptation is very different and deals with the underlying drivers of vulnerability. As you know, people are much more vulnerable to climate change if they're poor, less educated, unhealthy, and lacking access to services like disaster management and sanitation. The task within these countries and communities is to cultivate community-based, proactive adaptation that includes literacy programs, creative irrigation and crop rotation, and planning for heat stress or food shortages. There's clearly a role here for wealthier nations too. Ironically, the majority of greenhouse gas emissions have historically come from the industrialized West, while most of the impacts are suffered by people in the global South. This suggests that wealthier nations have a responsibility to support development in the regions that will be most deeply affected by climate change. To some extent, official development assistance and humanitarian programs have been doing this for decades, but climate change can be woven into these plans to prioritize regions and communities that may be especially vulnerable to climate change. Research has conclusively shown that literacy, nutrition, education, and security of livelihoods are important components of resilience to future climate change impacts. The third category of climate change adaptation responses pertains directly to projected impact. As we explore future climate change scenarios, we gain a better idea of the actions that are required to protect ourselves against potentially catastrophic events. City planning that contributes to distributed energy generation, a secure food supply, and protected vital infrastructure falls into this category. Technological solutions are one option here, including better insulated buildings, reflective roads and walls, and built-in cooling systems, not air conditioning, because this would ironically increase our greenhouse gas emissions and create a trade-off for climate change mitigation. There are also administrative solutions that we can put into place. Examples are weather warning systems, policies that encourage tree planting, and emergency management plans to address the impact of heat waves on the vulnerable. Finally, we can actually explore simple personal behavioral solutions like maintaining hydration, wearing less formal clothing, or even changing our work hours. A key part of adaptation is simply understanding more about the drivers and impacts of climate change. We need greater certainty in our scenarios and a better understanding of how human systems will respond to predicted changes. The science and social science of climate change must continue to improve in order to support adaptation. A really important dimension of this continued learning is what we call participatory scenario development. The creation of scenarios about the future has typically been the domain of scientists, but we know that the complexity of human behavior and governance is one of the biggest question marks in our scenarios. This means that we need more voices at the table. Some of the most robust and valuable scenarios of emissions and impacts and adaptation come from a participatory process. These processes allow the sharing of traditional knowledge about ecosystem changes and allow different groups to voice their views about what a desirable future might look like. It's not good enough, though, just to have these processes and not use what they create. Part of the challenge of adaptation is to feed the products of these scenario processes into decision-making and also create opportunities to shift our decisions as new information emerges. In other words, we need to adaptively manage our communities to account for shifting values, priorities, and information. We'll discuss this in greater detail in the last module of this course. A newer approach to climate change adaptation, and actually mitigation as well, is called ecosystem-based approaches. This holds out the promise of delivering on multiple priorities simultaneously, rather than just one. Ecosystem-based approaches mean we use living systems, like forests and wetlands, to do the work of traditional gray infrastructure. An example is using a series of salt marshes or wetlands to capture and purify stormwater, rather than burdening our sewage systems and risking floods. Another example is using oyster reefs to protect coastlines from wave action or storms, rather than simply building a bigger wall. Using a green infrastructure approach, rather than gray infrastructure, can have a number of benefits. One of the most important is that we can achieve, as I mentioned, a number of our goals at the same time. For instance, we can use that wetland to deal with stormwater runoff created by increasingly severe extreme precipitation events, but it will also sink carbon, create a recreational area, conserve biodiversity, and enhance the aesthetics of our communities. Sustainability isn't just about reducing our emissions or protecting ourselves against the impacts of climate change, but rather about creating communities that are healthy, beautiful, and resilient. As you can imagine, there are costs associated with ecosystem-based approaches too. This is new territory, so the financial costs can be higher in the short term than they might be for improvements to our current sewage system or building a bigger dike. There are also challenges with management. In many places, it's clear which agency or division deals with stormwater management, but now we need a new group of people on board. We need landscape architects, conservation biologists, urban planners, and stormwater engineers. All of these people would participate in the design of ecosystem-based approaches to adaptation, so things can get a bit complicated. With that said, though, communities around the world are starting to really test out ecosystem-based approaches to adaptation. They're only just starting to share the lessons they've learned so that other communities can do the same. One community is taking ecosystem-based approaches very seriously as part of a broader community transition towards sustainability. The neighborhood of Augustenborg in the city of Malmö, Sweden, was plagued by floods from overflowing stormwater systems and was also facing socioeconomic decline. Rather than building a bigger set of pipes, Augustenborg used what they call a sustainable urban drainage system to deal with increased runoff and waste management. The system of wetlands and drainage swales is currently in place, and it's doing the job of managing stormwater while also sinking carbon, providing a beautiful landscape for residents to use. It's also helping to preserve habitat for bird and amphibian species at significantly lower costs than traditional infrastructure in the long term. Another example of adaptation is happening in the Maldives. The Maldives is a nation of islands in the Indian Ocean, and it's the planet's lowest lying country. Around 330,000 people live on 192 islands, many of which are exposed to significant wave action and the threat of rising sea levels. In response to this risk and also spectacular damage that resulted from the 2004 tsunami, the government has begun constructing safe islands. These are literally the product of dredging sand from the ocean floor and building a new island that has a larger buffer zone between settlements and the ocean. Renewable energy, waste management, and coral reef preservation is also part of the Safe Islands approach in the Maldives. In this lecture, we've been introduced to specific strategies that can help our communities adapt to a changing climate. It's important to remember that there are both biophysical and human dimensions of this adaptation, so we need to consider the underlying drivers of vulnerability, as well as the technical or ecological tools that we have at hand to deal with impacts. I encourage you to learn more about adaptation that's going on in your own community. Think about vulnerable populations where you live and strategies that might be implemented to protect your community as we move into the future.